This material is for City College Math 60, Tuesday, March the 31st, Section 7.1, page 592 in Mel Ham's class. This material will not be covered on this Friday's exam. This Friday's exam, which I've already sent to you as a practice test, will be on Chapter 6. So we're just going ahead like we did when we met face-to-face. This section is on square roots and radicals. Problem 25, negative the square root of 64. The negative means your answer is just going to be negative. The square root of 64, you're really asking what number times itself will give me 64. That, of course, is 8, so the answer is negative 8. The negative because there's a negative over here. Problem 29, the square root of 0.25, you're asking for what number times itself gives us 0.25. That comes out to be 0.5. You have to be careful about that a little bit. We know 5 times 5 is 25, but 0.5 times 0.5 is 0.25. You could also get that on your square root button on your calculator, which I'll try to demonstrate shortly. 31 might be a little bit tricky. The square root of negative 81 we're saying is not a real number. There's no real number times itself that will give you a negative 81. We know it's not 9 because 9 times itself, 9 times 9 is 81. But negative 9 is not the answer either because negative 9 times negative 9 is a positive 81. It's not going to be a negative 81. We want a number times itself to come out with negative 81. There's no real number that does that. Number 35 asks for a calculator approximation to the square root of 12. So to square root of 12, see if I can show that to you here. It looks like we came out to be something like 3.4641. We're looking for the square root button. And on my calculator, the square root button is something like this. You can see the square root perhaps on it. And different calculators have a different location, but it's a square root button. So I punched a square root of 12 on my calculator, and it comes out to be about 3.4641. For 39, 43, 47, I'm changing the assignment a little. I'm going to make the assumption that x is non-negative, and here x is non-negative, and likewise this expression is non-negative. It becomes a little bit different than what it is in the book. I'm going to make it a little bit easier on you and assume that x can only be positive or perhaps 0. And likewise here and for the expression all the way here. The square root of 4x squared, we're asking what times itself gives us 4x squared. Well, 2 times 2 is 4, and x times itself gives us x squared. So the answer to this problem is 2x because 2x times 2x is 4x squared. For 43, the square root of 36x to the 6. So we can ask what number times itself gives us 36. That's 6. And then what object times itself, it's something times the same thing, gives us x to the 6. That would be x cubed, or x to the third power. So the answer is 6x cubed. In other words, 6x cubed squared, or 6x cubed times another 6x cubed, is 36x to the 6. 47 is a little bit tricky. But the thing to realize is that y squared minus 2y plus 1 can be factored into y minus 1 squared, or y minus 1 times another y minus 1 if you try to factor with the parentheses. This is y minus 1 squared, and now I see, oh, I have a square root of a square, and we leave it as y minus 1. Again, making the assumption that this expression does not come out to be negative. 51 asks to graph the function f of x equals negative square root of x. So I make a table of x and y. Remember that y is the same as f of x. So you could replace f of x with a y, but of course f of x tells us that it's a function. For every x value, there's only one y value, and so forth. And the graph would have to pass the vertical line test, which this graph does. So what was given was 0, 1, 4, 9, 16. We know the square root of 0 is 0, the square root of 1 is 1, and so on. But since there's a negative in front of the function, all of these are going to have a negative. So if I plug in 0, I have negative 0, but negative 0 is the same as 0. If I plug in 1, the square root of 1 is 1, but the negative in front of the whole thing gives us a negative 1. If I plug in a 4, the square root of 4 is 2, but the negative in front of the whole thing makes it negative 2. Likewise, if I plug in 9, I'm going to get negative 3. 16, I'm going to get a negative 4. So I make a graph, and notice the way I made the graph. I only have positive numbers from 0 to 16, so I did not devote any space here, here, or here. And it's basically a fourth quadrant graph. I'm not going to have anything up here or here or here, so I don't devote space to it. So I went all the way out 16 spaces to the right because that's the biggest number that I have here. And then vertically I go down to -4 because that's the biggest number that I have here. So I plotted 0, 0, the origin. 1, -1 is here. 4, -2, 1, 2, 3, 4, 1, 2 is there. 9, -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, -1, 2, 3, and 16, -4. So my graph is something like this. And notice I put an arrow on this side, meaning the graph does continue, but there's no arrow here because the graph does stop right there. And the problem also asks for the domain and range, the set of all possible x values, where we're not allowed to have any negative values for x. We are allowed to have 0, and we're allowed to have anything bigger than 0. So the domain is a bracket from 0 to infinity. You might recall infinity and negative infinity always use parentheses. For the range, well, this can go as low as you want, so negative infinity, but the highest, the largest value that y could have is 0, including 0. So the range is from negative infinity to 0 with a bracket including the 0. 55 and 59 just ask for the domain of the function f of x equals the square root of x plus 6. If we're asking for the domain, if I can just cover up this expression just for a moment, we know we're only allowed to take the square root of non-negative values. That means positive or 0. So the thing behind my pen has to be greater than or equal to 0. In other words, x plus 6 is greater than or equal to 0. And simply by subtracting 6 on both sides, we have x is greater than or equal to -6. So the domain is bracket -6, bracket because we're including the -6. And then for anything bigger than -6, we put infinity, and once again, infinity always has parentheses. 59, s of t. Again, you shouldn't be bothered by s of t. They could say f, but if they say s of t, same thing, it's a function, is equal to square root of 9t minus 4. What is the domain? Well, once again, because it's a square root, if I can just cover this up for a moment, the square root of anything has to be greater than or equal to 0. We're not allowed to take the square root of negative numbers. So the thing behind my pen, the 9t minus 4, has to be greater than or equal to 0. So I'm just solving this inequality. Add 4 to both sides. 9t is greater than or equal to 4. Divide both sides by 9. T is greater than or equal to 4/9. So the domain is bracket 4/9. Again, bracket meaning include the 4/9, comma, infinity. And once again, infinity always has a parenthesis, and negative infinity back up here always has parentheses too. 63 and 65, they just ask you to plug in certain numbers. So your given function f of x is the square root of 3x plus 1. So f of 8, I just plug in 8. So plug in 8, 3 times 8 plus 1. 3 times 8 is 24. 24 plus 1 is 25. So I'm taking the square root of 25, and that comes out to be 5. They want f of -2. So I plug in -2, square root of 3 times -2 plus 1. 3 times -2 is -6. Add 1, it's -5. I'm taking the square root of -5, which for now we will call undefined. Now later on in this class, we actually will tackle the square root of some negatives, but we're not there yet. So for now, we will just say undefined. Finally, for 65, g of x is the cube root, not square root, but this 3 means a cube root of x minus 4. So g of 12, so I plug in 12, cube root of 12 minus 4. 12 minus 4 is 8. And now I want the cube root of 8, not the square root of 8, which is actually not a nice number. It's something like 2.8. But the cube root of 8 is a nice number. It's 2. We're asking what number cubed, what number times itself 3 times, what number times itself will come back with 8. And that number is 2, because 2 cubed, or 2 times 2 times 2, is equal to 8. And then for part B, g of -23, so I plug in -23 right here. So I'm getting a cube root of -23 minus 4. -23 minus 4 is -27. And I am allowed to take the cube root of a negative number. I can't take the square root of a negative number for now, but we can take the cube root of -27. That comes out to be -3. Because if you ask yourself what number times itself will give me a -27, in other words, what number cubed is -27, that's -3, because -3 cubed, or -3 times -3 times -3 is equal to -27. So these are notes for 7.1, page 592. Once again, I'm going faster than I would in class because everything's already pre-printed, and of course you can fast forward or rewind as often as you wish from this video.